Good morning, guys. We're going to start chapter 4.7, which is congruent transformation notes. So we're going to talk about 3 different types of transformations. The first type of transformation is a reflection. So it says a reflection or a flip is a transformation over a line called the line of reflection. Each point of the pre-image and its image are the same distance from the line of the reflection. So if you look at the blue triangle and you see how it flipped over that pink line and turned into the green triangle, this is a reflection because it flipped across the line. The second type of transformation is a translation. A translation or a slide is a transformation that moves all the points of the original figure the same distance in the same direction. So again, if we start with the blue triangle, notice how all it did was move. It slide over. So from the blue to the green, all it did was slide in that direction. And then lastly, we have a rotation. So a rotation or a turn is a transformation around a fixed point called the center of rotation through a specific angle and in a specific direction. Each point of the original figure and its image are the same distance from the center. So imagine, I don't know if you guys used a protractor before, but just imagine you have a pencil, right? And you have a string attached to that pencil. If you hold the pencil in a position and you move the string around the pencil, that string will only be able to rotate around the pencil. It won't be able to go in a different direction. So what this triangle is doing, this blue triangle, is it's rotating or it's turning around that point and turning into that green triangle. So it's just turning. So let's look at some examples. So in example 1, it says identify the type of congruence transformations shown as a reflection, translation, or rotation. So we have to label each of these. So let's see the same thing that are blue polygons in this case. Our blue polygons are the original. So if we look at our original, okay, let me get the notes. If we look at our original and see what's happening to our green one, this one looks like it is turning around the origin. So it's turning around. So we know that if it's turning, this is called a rotation. Okay, let's look at B. Here's our original one. Okay, notice the direction of that blue polygon. And then notice the direction of the green one. They are now going in opposite directions. So that means they had to flip across this axis. And remember, if something flips, we call that a reflection. Okay. Lastly, starting with this blue polygon and looking at the green one, it looks like they are facing in the same direction, but the green one is just on top now. So that means it moved to the top. So it slid. And another word for that is translation. So make sure you know these vocabulary words, and these vocabulary words would be good words to add to your Quizlet deck, your Quizlet deck, vocab deck. Okay. Example 2 says refer to the information at the left. I forgot to copy that down, but I'm going to explain to you what is over to the left. Identify the type of congruence transformation shown in the diagram as a reflection, translation, or a rotation. So I don't know if any of you guys know what a skip-it is. It was a toy that you would put around your ankle, and it would have a flashing ball at the end, and you would turn this toy around your ankle and you would jump over the ball. So almost like jump rope, but by yourself. And so this diagram right here is illustrating that. Let's say this is someone's foot, right? And this green part's the toy. Let me change the color. So this part that I'm outlining in red, that's the toy. This part's the toy. And here's the original ball at the end of the toy. Well, if she's constantly turning it around her ankle and skipping over it with her other leg, that turning motion we would call a rotation. A rotation. So that's the answer. Okay. Let's think of other real-world examples. Let's say you have a minivan. So the type of minivan I'm talking about, it has the door that slides open, that doesn't just open up, it slides open. So that door you would call a translation because it slides open instead of opens up. So I know I didn't copy the picture, but let me draw this car. So here's my minivan, really poorly drawn minivan. Okay, and here is the door that slides open. So here's the little handle. Slides open and close. So this door would be called a translation. Okay. So this toy was the rotation. Okay. Now let's look at another example. Let's say you're at the beach, right? And you know when you're walking in the sand, your feet leave footprints in the sand. So let's pretend this is the sand, and these are your feet that are in the sand. Let me add some toes. There's your feet. Okay. Your feet would be a representation of a reflection, because if we were to draw a line here, we could flip your footprint over and it would be exactly the same. So this one is a reflection. So these are just real world examples of the things we just talked about. I'm trying to write this look a little nicer. There we go. Okay, let's look at example 3. Let's do some actual math here. Okay, so it says triangle XYZ with vertices XYZ is a transformation of triangle ABC with vertices ABC. Graph the original figure and its image. Identify the transformation and verify that it's a congruence transformation. Okay, so first thing first, we're going to have to graph. Sorry, excuse me. We're going to have to graph our two triangles. So I am going to change my color here. Okay, so let's go ahead and draw a graph. Okay, let's start with the first triangle, XYZ, and I'm going to do that in red. So XYZ I'm doing in red. So I'm going to plot all of these points. So X is 2, -8. So 1, 2, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's X. Z is 6, 7. 3, 4, 5, 6. Sorry, 6, -7. Z. And Y is 4, -2. Okay. There's my first triangle. And then the other triangle I'm going to do in blue. So triangle ABC. So triangle A is 2, 8. 1, 2, 3, 4, 5, 6, 7, 8. That's A. B is 6, 7. So 1, 2, 3, 4, 5, 6, 7. It's B. And then C is 4, 2. 1, 2, 3, 4, 2. Okay. So now I graphed my two triangles. now we have to determine the distance for each part of the triangle. Okay, so first I'm going to find the distance from A to B. And I'm going to leave this in blue so you know which one I'm talking about. So I'm finding the distance from A to B. Well, remember, in order to find the distance, we have to use the distance formula. And the distance formula, let me write it off to the side, is D is equal to the square root, you should have this memorized by now, x2 minus x1 squared plus y2 minus y1 squared. Okay, and I'm going to be using the points A and B up in our problem. So I have the square root of x2, so let's do 6 minus 2 squared plus 7 minus 8 squared. Okay, boom, boom. So AB is equal to the square root. 6 minus 2 is 4. 4 squared is 16. Plus 7 minus 8 is negative 1. Negative 1 squared is 1. So the square root of 17. So this one is the square root of 17, that distance. Okay, now let's do BC. Distance of BC. So that's going to be, we're now using these points, B and C. So 4 minus 6 squared plus 2 minus 7 squared. So then this is equal to, 4 minus 6 is negative 2. Negative 2 squared is 4. 2 minus 7 is negative 5. Negative 5 squared is 25. So this is equal to the square root of 29. So that's this part. Now we have to do AC, so the last side of the triangle. So AC is going to be 4 minus 2 squared plus 2 minus 8 squared. 4 minus 2 is 2. 2 squared is 4. 2 minus 8 is negative 6. Negative 6 squared is 36. So that means we get the square root of 40. Square root of 40. Okay, now we have to do the same thing with the other triangle XYZ. And I'm going to change my color to red so we can see the difference. So now I have to find XZ. So XZ, square root of 6 minus 2 squared plus negative 7 plus 8 squared. And I'm going to get the square root of 17. So square root of 17. ZY, I get, let's look at my points. ZY, so I get 4 minus 6 squared plus negative 2 plus 7 squared. And I get the square root of 29. You guys see the pattern that's happening here? So ZY, square root of 29. And then lastly, I have to do XY. So I'm going to get 4 minus 2 squared plus negative 2 plus 8 squared, which is going to give me the square root of 29. Oh wait, not 29, 40. My bad. Did the math wrong. 40. Okay. Okay. Since, if you look here, we have 3 sides that match. So let me change my color real quick so I can draw those little hash marks. So this side matches with this side. This side matches with this side. And this side matches with that side. So since all 3 of our sides are congruent, that means our triangles are congruent. So since all 3 sides are congruent to all 3 sides on the other triangle, then by side, 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 triangle XYZ is congruent to triangle ABC. Okay? Now we need to see what type of transformation this is. We need to see if it is either a reflection, a translation, or a rotation. So, says, use the definition of a reflection. Use a ruler to measure and compare the segments connecting each vertex and its image to the line of symmetry. These segments are congruent, so the triangles are congruent. So right here, if we were to take the distance from each congruent point, so the distance from here to here, here to here, and here to here, these distances will be congruent to each other. So this would be congruent to this distance, these distances to this one, and these distances to that one. Well, since all the distances are congruent, it looks like it is flipping over the x-axis. And remember, something that is flipped, we call a reflection. Okay, so since the distance from each point is the same to the x-axis, this shows that the triangle flipped over the x-axis, and we call that a reflection. So that's our answer. Okay, go ahead and start working on homework 4.7 and comment below if you have any questions.